The feed rate is the rate at which feed mixture is pumped to a column. The flow of feed to a column can affect the quantity and quality of overhead product and bottoms product. For that reason, an optimum feed rate is normally determined mathematically based on system equipment and the materials being processed. If a system's feed rate is too high, overloading can occur. Overloading is a condition in which the vapor rising up a column is impeded by the liquid flowing down the column. If the feed rate to a distillation column is too high, overloading and flooding can occur. But the performance of a distillation system can also suffer if the feed rate is too low. For example, if the feed rate to the column in this system decreases, the level of condensed overhead vapor in the receiver and the level of liquid in the bottom of the column will start to drop. As a result, less liquid will be available for reflux and for circulating through the reboiler. In a typical distillation system, overhead vapor from the column flows to a condenser, where it's cooled and turned back into a liquid. In this system, the condensed liquid collects in a tank called a receiver. During startup, all of the condensed liquid is pumped back to the top of the column as reflux. Reflux cools the top of the column to keep it within a specified temperature range. It also helps condense heavier fractions that may have vaporized to improve the separation of bottoms product and overhead product. Once the system is operating normally, only part of the liquid is returned as reflux. The remainder is routed to overhead product storage. The ratio of the amount of liquid that's returned to the column as reflux to the amount that's sent to overhead storage is known as the reflux ratio. For example, if 4 times as much liquid is returned to the column as is sent to overhead storage, the reflux ratio is 4 to 1. The more liquid that's returned to a column, the greater the reflux ratio. Whether a reflux ratio is high or low depends on the design of the column and the mixture that's being distilled. For example, this mixture is made up of components that are hard to separate. A mixture whose components are hard to separate generally requires a high reflux ratio. On the other hand, a mixture whose components are easier to separate generally requires a lower reflux ratio. Maintaining the proper reflux ratio for a system is important because it can affect the equilibrium between the rising vapor and the falling liquid in the column. If that equilibrium is upset, the performance of the column will suffer. In this system, the reflux flow is regulated by a temperature controller that adjusts a valve in the reflux line. If the reflux rate is too high, too much liquid will flow down the column, and the top of the column will be cooled too much. As a result, too much vapor will condense before it reaches the top of the column, and the column could flood. Now, if the reflux rate is too low, there won't be enough liquid to flow down the column or to cool the top of the column properly. This could disrupt product separation. For example, heavier uncondensed vapor could rise up the column, mix with the overhead vapor, and be carried into the overhead condenser. In a distillation system, a condenser removes heat from the overhead vapor and turns the vapor back into a liquid. 2 common types of condensers are water-cooled shell and tube condensers and air-cooled or fin fan condensers. Both types of condensers can experience problems. Many condenser problems are related to the cooling medium that flows through the condenser. These types of problems can ultimately affect the amount of cooling provided by the reflux. For example, if the cooling water flow through this shell and tube condenser is lower than normal, or if the water temperature is higher than normal, the temperature of the reflux may increase. As a result, less cooling could occur in the top of the column. This could cause heavier uncondensed vapor to rise too far up the column, mix with the overhead vapor, and be carried into the overhead condenser. Some common conditions that can reduce the cooling water flow through a shell and tube condenser are improper valve settings, problems with the cooling water pump, and deposits in the condenser tubes caused by impurities in the cooling water. In a fin fan condenser, the cooling medium is air. One of the main problems that can reduce the flow of air through a fin fan condenser is a problem with the fans. Also, some fin fan condensers have louvers to help control airflow. In these condensers, airflow can be reduced if the louvers stick in the wrong position. In this topic, we saw how problems with the reflux can affect a distillation system, and we identified some condenser problems.